Hello viewers, in my previous video on quadrilaterals, I have explained what is a quadrilateral, its different types and the properties of each of them. And in this video, I am going to do sums of chapter 8. Let's start with exercise 8a number 1. The question is, three angles of a quadrilateral are respectively 40 degree, 50 degree and 110 degree. We are to find the fourth angle. Let us assume ABCD be a quadrilateral in which angle A equals to 40 degree, B equals to 50 degree, C equal to 110 degree, and we are to find angle D. Clear? Now, in the solution part, what we have to do? Since sum of four angles in a quadrilateral is 360 degree, we know this is the angle sum property of a quadrilateral. So we can write angle A plus angle B plus angle C and angle D equals to 360 degree. Now A is known to us 40, B is 50, C is 110. So we'll replace these values and angle D is unknown, we'll keep as it is, equal to 360. If I add these three, I am going to get 200. 200 plus angle D equal to 360. Angle D is 360 minus 200. So that means angle D equals to 160 degrees. Therefore, fourth angle, that means angle D will be equals to 160 degree. In question number 2, it is given the angles of a quadrilateral are in the ratio 2:4:5:7 and we are to find the angles. Now for this, since angles are not given and their ratios are given, we can assume like this. Let the angles be 2x, 4x, 5x and 7x, where x is the common ratio. Fine. Now we know sum of four angles in a quadrilateral is 360 degrees, which is called the angle sum property. So twice x plus 4x plus 5x plus 7x will be equal to 360. Now if I add, I am going to get 18x equals to 360. So x will be 360 divided by 18. So x equals to 20. So angles are, first angle is 2x, so 2 into 20, 40 degree. Second angle is 4x, 4 into 20, 80 degrees. Third one is 5 into x, that is 5 into 20, 100 degree. And the last one is 7x, 7 into 20, that will give you 140 degree. So these are the four angles of the quadrilateral. In question number 3, it is given that in the quadrilateral ABCD, O is a point inside it. We are to prove that OA plus OB plus OC plus OD is greater than AC plus BD. Since no figure is given in the question, let me draw the figure. Suppose ABCD be the quadrilateral and O be any point inside it. Now, since OA, OB, OC, OD, these things are required, so we have to join OA, OB, OC and OD. And we have drawn two diagonals. AC is one diagonal and BD is another diagonal. These two diagonals are also drawn. So what we have written here, in quadrilateral ABCD, O is a point inside it. It is given in the question. AC and BD are joined. What we have to prove? OA plus OB plus OC plus OD. Sum of these four line segments is greater than AC plus BD. This is what we have to prove. To solve this sum, we have to use one property which we have done in Triangles chapter. The property is sum of any two sides of a triangle is always greater than the third side. Suppose AOC is a triangle, then I can write AO plus OC greater than AC. Someone can write AC plus CO greater than AO. So always sum of two sides will be greater than the third side. So here, since OA, OC are given, so what we can do, in triangle AOC, I can write AO plus OC is greater than AC. Clear? So we have written in triangle AOC, OA plus OC is greater than AC. Similarly, in triangle BOD, we can write BO plus OD greater than BD. Here we have written in triangle BOD, BO plus OD is greater than BD. Suppose this is our first part and this is our second part. If I add this first part and second part, what I am going to get? OA plus OC plus OB plus OD, OA plus OC plus OB plus OD greater than AC plus BD. So simply we are adding this one with this part. And now if we arrange in proper order, I am going to get OA plus OB plus OC plus OD is greater than AC plus BD, and this is what we have to prove. Now in question number 4, it is given that in the figure, as figure is given here, ABCD is a quadrilateral in which the line segments bisecting angle C and angle D meet at E. We have to prove angle A plus angle B is twice CED. So this is the quadrilateral ABCD, and DE and CE, these two line segments are bisecting these angles. That means these two line segments are dividing this angle and this angle into two equal parts, and we have to prove angle A plus angle B is twice angle CED. Here ABCD is a quadrilateral in which line segments bisecting angle C and angle D meet at E. This is given in the question, and we have to prove angle A plus angle B is twice angle CED. We have marked the angles as angle 1, angle 2, angle 3, angle 4 and angle 5. Okay, so we have written here angles are marked as shown. DE and EC bisects angle ADC and angle BCD. This is given in the question, so we can write angle 1 equal to angle 2, which is angle ADC by 2. Since it is given it has bisected, that means the line segment has divided this angle into two equal parts. So angle 1 will be equal to angle 2 equals to angle ADC by 2. And here also I can write angle 3 equal to angle 4 equal to angle BCD divided by 2. Fine. Now in triangle DEC, we know sum of three angles in a triangle is always 180. So we can write angle 2 plus angle 3 plus angle 5 is 180. So 2 plus 3, angle 2 plus 3 will be 180 degree minus angle 5. Let it be equation number 1. Now if you consider the quadrilateral ABCD, we know sum of four angles, this angle, angle C, angle D together, it will be 360, which is the angle sum property of a quadrilateral. Now angle A, angle B, what is angle BCD? BCD is nothing but 2 times angle 3, because we know this angle and this angle are equal. So instead of BCD, I can write twice of angle 3, and instead of angle ADC, we can write twice of angle 2. Fine, equals to 360. Angle A plus angle B plus, from these two I can take 2 common. I am left with angle 3 plus angle 2 equals to 360. Angle A plus angle B plus twice. Now what is 2 plus 3? From equation 1 already we got angle 2 plus 3 is 180 minus angle 5. So instead of angle 2 plus 3 from equation 1, we can write 180 minus angle 5 equal to 360. If you want, you can write using equation 1. Fine. So this equation you got. Now angle A plus angle B plus 2 into 180, it will be 360. 2 into angle 5, it will be twice angle 5 equals to 360. Now only A and B we are going to keep in one side and remaining in the other side. So if I keep angle A plus angle B, it will be equal to 360. This plus 360 will become minus 360, and this minus will become plus twice of angle 5. So angle A plus angle B will be 360 cancels. You are left with what is angle 5? Angle 5 is nothing but angle CED. So instead of angle 5, we can write twice angle CED, and this is what we have to prove. Question number 5. In the figure, this is the figure, BL perpendicular to AC, BL perpendicular to AC, DM perpendicular to AC, and it is given BL equals to DM. These three are given in the question. We have to prove that AC bisects angle BD. That means we have to prove BO equals to DO. I hope question is clear. Let me solve the sum. As given in the question, BL is perpendicular to AC, DM is perpendicular to AC, and BL equal to DM. We have written in the given part. what we are to prove? That AC bisects BD. So indirectly we can say we are to prove BO equals to DO. Now if you consider these two triangles, BLO and DMO, these two triangles we have to consider. So I have drawn it separately. Here this angle and this angle, these two angles will be equal. Why? Vertically opposite angles are always equal. So these two angles are equal. This is 90, this one is 90 given in the question, and this side equal to this side, this is also given. So if I use the congruence triangle property, angle side, we can prove that the triangles are congruent. So in triangle OMD and OLB, we can write angle DOM will be equal to BOL. These are vertically opposite angles. Next one, OMD equals to OLB. Both of them are 90 degree. And DM equals to BL. It is given in the question. So from the congruence property of angle side, triangle OMD and triangle OLB, these two triangles are congruent. And when two triangles are congruent, their corresponding parts must be equal, which is called CPCT. So since these two triangles are congruent, therefore OD must be equal to OB. So we can write OD equals to OB by CPCT, corresponding parts of congruent triangle. As AC has bisected the diagonal BD, hence proved. I hope all of you have understood the sums. So today I have completed 8A. In my next video, I am going to do sums of 8B. So that's all for today. Take care, bye bye, and wait for my next video.